Just a couple of simple examples of what we've shown here, that the square root of A times B equals the square root of A times the square root of B, but that we have fallacies if we think that the A plus B quantity squared equals A squared plus B squared, or if we think that the square root of A plus B is equal to the square root of A plus the square root of B. We get in big trouble in these cases. Square root of 4 times 9 equals the square root of 4 times the square root of 9, an example of this one, which is true. We can easily show that this is true. Square root of 4 plus 9 is the square root of 36. Square root of 4 is 2. Square root of 9 is 3. Square root of 36 is 6, equals 6. And using fancy mathematical language, yep, it's true. Okay. 2 plus 3 quantity squared is not equal to 2 squared plus 3 squared. Very easy to show this. 2 plus 3 is 5, so we'd have 5 squared. And 2 squared is 4, 3 squared is 9. 25 is not equal to 13. Square root of 16 plus 9 is not equal to square root of 16 plus the square root of 9. If we add 16 and 9, we get 25. That's not equal to 4 plus 3, which is square root of 16 plus the square root of 3, because 5 is not equal to 7. You should be able to prove these, at least with numerical examples. Now, this does prove that this is not a generally true statement. We didn't need to see why it's not a true statement, as we did with the distributive law, just to prove that it's a true statement, that the square root of A plus B squared is not equal to A squared plus B squared. Okay? This proves it. One example where it's not true says that this is, well, actually what we've proven is that A plus B squared equals A squared plus B squared is a false statement by showing a counterexample. Okay? And the statement square root of A plus B is equal to the square root of A plus the square root of B is a false statement. All you need is one counterexample and you can prove that this is false. So let's just clarify what's been proven here. This proves this statement to be false. This counterexample proves this statement to be false. And this statement doesn't prove anything. Because you can't prove a general statement like this by one example. You can disprove a general statement by giving one counterexample, here or here. Here we've only proven it for A equals 4 and B equals 9. This might make it plausible, okay? And it's important to show plausibility. So we've shown the general result is plausible, but we haven't proven it.